Using the percentages, you're able to use this to work out its mole. So remember, if you've simply got percentages, you just times it by 100, and therefore you end up with your percentage now being the mass. From there, for carbon, to work out its mole, you divide by 12. This gives you a mole of 4.0983. Then from there, you do exactly the same for hydrogen, nitrogen, and oxygen. When you've worked out their moles, we use this as our ratio, and you divide by the smallest. In this case, our smallest is oxygen, 1.0425. Once you have your ratios, you then can round up or round down where required. If this round up or round down is way too much, then you must do multiplications. In this case, it's not too bad. The empirical formula for our unknown compound is C4H5N2 and O. From here, we can now calculate the molecular formula. The first thing we need to do is to compare our empirical formula's molar mass to the molecular formulas. We know that there are 4 carbons, 5 hydrogens, 4 nitrogens, and 1 oxygen. So simply we use our molecular masses, so 12, 1, 14, and 16, to calculate the molar mass of our empirical formula to be 97 grams per mole. Now we need to do a ratio to work out the difference between our empirical formula and our molecular formula. So we simply divide 196 by 97, which gives us 2. So we now know we need to times our empirical formula by 2, which gives us the molecular formula of C8H10N4O2.